Let's get started with section 3.1, which is solving systems of two equations with two variables. This is mainly review, however, I think you'll definitely need a little refresh once we get to the word problems. So, what is a system of equation? It's simply two equations or more with the same variables. So, we're going to focus on a system with two variables, which means two equations. However, later on, we may focus with three variables, which then means we need three equations. A solution is the ordered pair or ordered pairs that make all equations true. So let's look at our three scenarios that could happen when solving systems. The first scenario that we could have is intersecting lines. So for example, here's one line and here's another. Okay, their intersection point is the solution. So when we have intersecting lines, there is one solution. We call this a consistent independent system. Okay? Coinciding lines. Coinciding lines mean the exact same line. So, for instance, we have one line here, and then on top of it, the exact same line is plotted. In that case, how many solutions do we have? Well, there are infinite amount of overlapping points, so there are infinitely many solutions. Be careful there that we do not say all real numbers. For instance, the point that the cursor is highlighting around is not part of that line. So we cannot say all real numbers, simply there are an infinite amount, all the points on the line. This classification is that it's consistent, meaning there's a solution, and it's dependent. They're the exact same lines. Our last scenario is parallel lines. So for example, we may have one line that we plot here, and then another line. And they are parallel. So how many times do they intersect? None. So there are 0 solutions. This is an inconsistent system. So if I wanted to determine just how many solutions I have, I don't actually have to go about solving the entire thing or even graphing the entire thing. Let's take a look at this first example. If I look at this first equation, I can simply just manipulate it into y equals mx plus b, slope-intercept form. I would add 2x, divide by 5, and find an equation of y equals 2/5 x plus 2. I would then take the second equation of 4x minus 10y equals negative 20 and do the same type of thing. Subtract 4x, divide by negative 10, and I get y equals 2/5 x plus 2. If I look at these two lines, I notice that they have the same slope and same y-intercept. Because they have the same slope and same y-intercept, that means they're the exact same line and they will coincide everywhere. So there are infinitely many solutions. So you want to rearrange into slope-intercept form and identify those slopes and y-intercepts. If the slopes are the same but y-intercepts different, we would have parallel lines. And if the slopes are completely different, then it doesn't matter what the y-intercepts are because the lines will intersect. You complete number 2 and number 3. Okay, now let's solve by graphing. we are going to take our first equation. We will add 4x, divide by -3 to put this into slope-intercept form. And now we will use the y-intercept and go down 4 over 3, or we can go up 4 over 3. And we can continue that. Use a straight edge and extend that line as far as you can, because we're not sure where an intersection may occur. And be sure to use a straight edge at home. Now we'll take our second graph and we will add x, divide by 3. Sorry, that's a plus. Y equals 1/3 x plus 1. Plot at y1, go up 1 over 3 or down 1 over 3. And we can see here that these lines are intersecting. So the solution is that intersection point, which I'll highlight in green. So we always state our solution as an ordered pair. So the solution is -3, 0. Okay. All right, now let's solve by substitution. Solving by substitution, if we take our first example, we try to solve one of the equations for a variable. Take the nicest, easiest one. And what do I mean by that? Ideally, one that has a variable already almost alone. So I'm going to solve for this second equation. I'm going to get the y alone. Y will equal -2x plus 7. I am now going to substitute that into the other equation. Do not put it back into the same equation. Make sure to substitute it into the second equation. So now I substitute that in for y, and I will solve. So we have 5x, make sure to distribute, plus 6x minus 21 equals 23. This will give us 11x equals 44. X then equals 4. Remember, a solution is an ordered pair. So now we have to figure out what the corresponding y value is. I'll plug it in right where y equals. So y equals -2 times 4 plus 7. Y equals -8 plus 7. Y equals -1. Therefore, my solution is 4, -1. You try number 6. How about elimination? The elimination method is to get rid of a variable completely so that we now have one equation with one variable. Let's do number 8 together. The first thing you want to make sure to do is that your variables are lined up on top of each other in somewhat pseudo-standard form. We don't need to worry about the fractions and negatives, but let's get our x's on top of each other, our y's on top of each other, and the constants. So I'm going to subtract the 2x. I now have -2x plus 5y equals 10. And then my second equation is already in the correct order. From that point, what I need to do is I need to get a variable so that it cancels. I can do that by multiplying the top equation by 2. When I multiply the top equation by 2, I now get -4x plus 10y equals 20. Okay, that's my new equation. I'll take that second equation that I had and just rewrite it. I did nothing to it. And now that I have two equations with a pair of opposites, I'm going to add them together. When I add the -4x and 4x together, it cancels. gone. 10y and negative 10y also cancels. What's left with is 0 on this left-hand side. And on the right-hand side, I also get a 0. What happened here is that the variables completely canceled, and it's a special case. I get a true statement. With a true statement, that means I will have infinitely many solutions. If I had a false statement, it would be no solution. And if one of the variables actually stayed around and I got like y equals 2, then I would actually have an ordered pair to find. You try number 7 using the elimination method. Okay, how about some word problems? We're going to look at 2 types of word problems. The other ones you should hopefully still remember and be okay with, but I know that our distance and rate and time ones and our mixture problems are usually a little rusty. So let's give those a whirl. The first one says an airplane flew for 3 hours with the wind of 40 kilometers per hour. The return flight against the same wind took 4 hours. So against the wind, it took 4 hours. Find the speed of the airplane in still air. So that's what we want to start with, is defining our variable. Find the speed of the airplane. Now there may be other unknowns too, so let's set up a chart and see what else we need to know. For our distance, rate, time problems, we're going to set up a chart and we're going to have 2 rows, but 3 columns. We're going to have distance equals rate times time. And this scenario, we're going with the wind and against the wind. Some distance problems, we might have train 1 and train 2, or an airplane 1, airplane 2, etc. And now we're going to fill in as much information as I know. So it says an airplane flew for 3 hours with the wind. With the wind, 3 hours is our time. So I'll plug in a 3. It says that the wind is 40 kilometers per hour. So that's not the rate of with the wind or against the wind. That's the rate of the wind. Then it says the return flight against took 4 hours. So I know a 4 goes here. Now remember, when you fly with the wind, you're going to move faster. So what happens is my rate is the rate of the plane plus the wind, which was 40. And when I go against it, I get slowed down. So my rate is x minus 40. We don't know the distance, but we know it was the same distance. So we can say y here. And then I'll go up and define that y is the distance. Now what we have, believe it or not, is 2 equations. Recall, distance equals rate times time. So I can have one equation that is y equals x plus 40 times 30, and y equals x minus 40 times 4. So let's do that. Now we defined our variables, put our information. Now we need to write those equations. So y equals 3 times x plus 40, and our other equation is y equals 4 times x minus 40. From this point on, I will clean those up and distribute. Y equals 3x plus 120, and y equals 4x minus 160. Now you decide what method is best to solve. Substitution, elimination, graphing. In this case, because we have them both equaling y, I will use substitution, and I'll set them equal to each other. So 3x plus 120 equals 4x minus 160. I'm going to subtract 4x. That would give me negative x. And I'm going to subtract 120. And that's going to give me negative 280. Which means positive x is 280. Now the question says, what's the speed of the airplane? Well, if we go back to our variables, x represents that speed of the airplane. So what that means for my final answer is that the speed of the plane in still air is 280 kilometers per hour. Always analyze your answers as well. We know airplanes travel fast. If you got something like 10 kilometers per hour, that wouldn't make much sense unless it was taxiing on the ground. But if we're flying in the air, an airplane should have a pretty high rate. Okay, now let's take a look at some sort of mixture type problems, or in this case, it's a sales commission based one. So Lex has a job offer in which he will receive $800 per month plus commission of 2% of the total price of the cars. At his current job, he received $1,200 per month plus a commission of 1.5%. How much must he sell per month to make the new job a better deal? So let's start off with defining variables. What are we looking for? How much must he sell for each month to make his new job a better deal? So X is the amount of sales. Okay? Y represents his income, or the amount of money he's actually making. So remember with commission is extra money that you receive. So one equation in this scenario for the first one, so Lex has a job offer, so here's the job offer, is his money will equal, no matter what, we're getting $800 plus commission of 2%. Remember when we write percents, we write them with a decimal and we move them 2 spots. So 2% of his sales tells me how much money he's going to actually be making. Our second equation is his current job, which is that he makes $1,200 plus a commission of 1.5, which is 0.015x. Now we need to solve that, okay? So how much must he sell per month to make the new job better? So if we set those, again, you determine whether you want to use substitution or elimination. It's up to you. I'm going to use substitution again since the y's are equal. So we will have 800 plus 0.02x equals 1,200 plus 0.015x. If I move my variables over, 0.02 minus 0.015 gives me 0.005x, and 1,200 minus 800 gives me 400. Now we divide. And this gives me x equals 80,000. So this is saying for the amounts to be the same, we would have to have $80,000 in sales. Okay, so for the jobs to bring in same income, the sales would be $80,000. So what does that mean? So the question says, how much must he sell to make the new job better? So this means Lex must sell more than $80,000 in sales. For it to be better. Okay, now that we have done examples of all different types of problems, you go on to finish and try some on your own.